Well, greeting bakers, and I hope everyone is doing well today. Let's talk about mise en place. And now everybody at this level pretty much understands mise en place. We've talked about it in Culinary 1. We've talked about it in Baking 1, Baking 2. Anywhere, any class you're in, mise en place is the thing. In fact, in this day and age, I even have a mise en place mask that I should be wearing these days. But mise en place goes in a little bit deeper. What we're going to talk about beyond the standard mise en place is measurements and volumes and weights, and we're going to talk about conversion factors. So some of this is a review. It should be a review for everyone, but this is building up to the fact that we're going to be doing a lot of costing. And before you can cost, you have to be able to convert and to know where your recipes and formulas are at. So let's look here after we're done with this section. We'll be able to understand the importance of formulas and recipes in the bake shop, understand measurement systems and how to measure ingredients, and explain the importance of weighing ingredients. Excuse me, it's not morning time apparently. After studying this chapter, you're also going to be able to convert formulas and use the baking percentages. Most of you already can. Understand the importance of knife skills in the professional kitchen and prepare items needed prior to actual cooking or baking. All right, so let's look at formulas and recipes. As in the scientific laboratory, many basic recipes in the bake shop are referred to as formulas, um, perhaps in reference to the scientific nature of what seems like the magic of baking. Using the same preparation method, a product may bake into something entirely different when the ratio of ingredients is altered. For example, if the amount of fat in a formula for pie dough is increased, but the type of quantity of other ingredients are not adjusted, the result may be a product that bears no resemblance to what was intended. The first step when making bake shop items is to become familiar with the formulas and the intended result. Read the formula carefully to identify any special steps that may be required. Locate and prepare all of the equipment needed to complete the task. Select and prepare any ingredients called for in the formula. Often, these ingredients, such as butter or for creaming into a pound cake, need to be brought to the proper temperature, which requires forethought and planning, as does making sure you have enough ingredients. This is what mise en place is for, so that you have a plan, and so you are completely prepared to put the formula together. Sip of coffee time, you guys know me. When there's ever a long pause, it's usually a sip of coffee time. Okay, you guys know me and my coffee. So measuring the precise, accurate measurements of ingredients is extremely important for bake shop products. To reproduce products consistently and for the same cost day after day, it is important that the ingredients be measured accurately each time. In a kitchen, measurements may be made in three ways: weight, volume, and count. Weight refers to the mass of heaviness of a substance. It is expressed in terms such as grams, ounces, pounds, kilograms, tons. Weight may be used to measure liquid or dry ingredients. For example, 2 pounds of eggs for a bread recipe, and portions, for example, 3 ounces of hot fudge for a sundae. Weight is the most accurate form of measurement and the one most commonly used in the bake shop. Volume refers to the space occupied by a substance. This is mathematically expressed as height times width times length. It is expressed in terms such as cups, quarts, gallons, teaspoons, fluid ounces, bushels, and liters. Volume is most commonly used to measure liquids. It may also be used for dry ingredients when the amount is too small to be weighed accurately without specialized equipment. For example, 1/2 teaspoon of salt. Formulas in this book include the approximate volume measurements of ingredients that weigh less than 1/2 an ounce. Use these measurements when a scale is accurate for weighing small quantities. is unavailable. So that's how your On Baking book measures things below a half an ounce. Cooks will assume that 8 ounces of flour is the same as 1 cup of flour, commonly making errors in the bake shop. In fact, 1 cup of flour may only weigh 3 to 5 ounces, and Culinary One experiment we did when you were a freshman showed that a cup of flour is approximately 5 ounces, and 3 people getting a different cup of flour get different results. So keep that in mind. That is why weight is so vitally important in the bake shop. Measuring ingredients by weight, commonly referred to as scaling, is more accurate. Therefore, baking formulas often use weights even for liquid ingredients. Count. Count refers to the number of individual items. Count is used in formulas, for example, 4 grapefruits, and in portion control, for example, 1 poached pear. Count is also commonly used in purchasing to indicate the size of an individual item. For example, a 96 count case of lemons means that a 40-pound case contains 96 individual lemons. A 115 count case means that the same 40-pound case contains 115 individual lemons. So each lemon in the 96 count case is larger than the lemons in a 115 count case. Does that make sense? I hope so. Coffee broth. Measurement formats. The U.S. system is ounces, pounds, inches, feet, and it's not as accurate. The U.S. system is actually a more difficult system to understand. It uses ounces and pounds for weight and cups for volume. The metric system, on the other hand, is much easier to understand because it's a base 10 system. Most commonly used in the world, everywhere except the United States. Developed in France during the late 18th century, it was intended to fill the need for a mathematically rational and uniform system of measurement. The metric system is a decimal system in which the gram, liter, and meter are the basic units of weight, volume, and length, respectively. Larger or smaller units of weight, volume, and length are formed by adding the prefix to the word gram, liter, or meter. Some of the most commonly used prefixes in food service operations is deca, 10, kilo, 1,000, deci, 110, and milli, 1/1000. Thus, a kilogram is 1,000 grams, a decameter is 10 meters, and a millimeter is 1/1000th of a liter. Because the metric system is based on simple multiples of 10, it's extremely easy to increase or decrease amounts. Table 5.2 on page 123 of your book lists a common equivalent measurements. Take a look at that. It's up here on the slide as well. Whether it produces 6 servings or 60 servings, 3 pounds or 30 pounds of dough, every formula is designed to produce a yield, which is a specific amount of a product. The yield may be expressed in volume, weight, or servings. Excuse me. For example, 1 quart of sauce, 8 pounds of bread dough, or 8.5 cup servings. The yield for the formula in this book may be expressed by unit and by weight, such as 60 cookies, 3/4 ounce each. If you increase the weight of each piece of dough during scaling, fewer cookies will be obtained. The weight listed is calculated before baking. Remember that the weight of the finished bread, cake, or cookie will change because the moisture lost during baking. Formulas for some icings and creams are expressed by volume, such as 2 quarts or 2 liters of Bavarian cream. Volume measure is useful when calculating the number of servings of each product, which are normally presented in a mold or cup. If the stated yield of a formula is not what it is needed, the ingredient amounts must be decreased. must be converted to produce the desired quantity. Increasing or decreasing a formula is also referred to as scaling up or scaling down. Two-step process. Step 1. Divide the desired new yield by the formula old yield to obtain the conversion factor. New yield divided by old yield equals conversion factor. Example, if your recipe made 2 and you wanted it to make 1, the new yield would be 1, the old yield would be 2. 1 divided by 2, or 1/2, equals your conversion factor. If you take that 1 divided by 2 in a calculator, you would get 0.5, and that would be your conversion factor for use in a calculator, which I teach you guys in class. Step 2, take the old quantity of a product. Okay, each ingredient quantity by the conversion factor equals the new quantity. So if it required 3 lemons and your conversion factor was 0.5, your new quantity would now be 1.5 lemons. Hopefully that all makes sense to you. How about if we do a formula for grapefruit sorbet? The present formula yields 1.5 quarts, but only 3/4 of quart is needed. Wow, that tells me I'm going to go half. Determine the conversion factor. 0.75 quart divided by 1.5 quarts equals 0.5, half. Look at that. Note that any unit can be used as long as the same unit is used with both the new and the old formulas. In other words, you need to have a common denominator. You need to have the same measurement for both. 24 fluid ounces divided by 48 fluid ounces equals 0.5. Okay. Apply the conversion factor to each ingredient in the recipe, and you see it listed there. I'm not going to go through those one at a time. Okay. But you see it breaks down 1 quart times 1 times half, 1/2 quart. 8 ounces times 1/2, 4 ounces. 1 fluid ounce, 1/2. So it breaks it down pretty easily. Converting portion size. Formula conversions is sometimes complicated by portion size conversions. For example, it may be necessary to convert a formula that initially produces 24 2-ounce servings of ice cream for a formula that produces 62 4-ounce servings. Sometimes the amount of food served as a portion must be changed. For example, a new muffin pan may hold less batter than one that is being replaced. Or a new plated dessert may require a smaller portion of ice cream than a single service of ice cream by itself. A few additional steps are necessary to convert formulas when portion sizes must also be changed. This is easy to understand in terms of total amount of food items that is needed in relation to total amount of items. It's the yield. The key is to find the common denominator for the new and old formulas: ounces, grams, cups, servings, whatever your common denominator is. Any unit can be used as long as the same unit is used with both the new and the old formulas. Step 1. Determine the total yield of the existing formula by multiplying the number of portions by the portion size. You have to have the total yield. Number of original portions times portion size is the total amount of the recipe. Step 2. Determine the total yield desired by multiplying the new number of portions by the new portion size. Step 3. Obtain the conversion factor as described earlier. New divided by old equals conversion factor. And step 4. Multiply each ingredient by the quantity of the conversion factor. Makes sense, right? We're going to return to our sorbet. Oops, let me leave this here. The original formula produced 1.5 quarts or 24 2-ounce servings. Now you need 36 3-ounce servings. Total original yield 24 times 2 equals 48. Total desired yield is 36 times 3 equals 108 ounces. So now your conversion factor is 108 is the new, divided by 48 is the old, giving you a 2.25 conversion factor. Please get with me if you're confused at this point. It is also on page 125 of your textbook, and that will be helping you to see that example. So you might work through that on page 125 and 126. When making significant changes to a formula yield, for example, from 5 to 25 portions or 600 to 300 portions, you may encounter additional problems. The mathematical conversions described here do not take into account changes in equipment, evaporation rates, unforeseen formula errors, or cooking times. Pastry chefs and bakers learn to use their judgment, knowledge of cooking principles, and skills to compensate for these factors. Other things that don't convert well we found in culinary and sometimes in the bake shop as well: peppers, salt, things along those lines do not convert mathematically when dealing with large amounts. So that's something you must keep in mind. Baker's percentage. This seems to have been an easier task to explain over the last few years. So I'm glad of that. I'm glad that you guys are beginning to get it. This seemed to be a problem in years past. So I think everybody who's going to get this presentation this year has a pretty good idea about Baker's percentages. But let's refresh our memory anyway. I do know that anybody going on to college for baking will understand baking percentages, and as long as I've drilled it in your head, you'll be far ahead of the game. I know one of my students who went off to Johnson and Wales always came back and said, "Yeah, well, the professor said, here's the baking percentages, figure it out," and we were on our own. And after doing mine and helping everybody else in class, we were done. Not a problem. So thank you, she said, for drilling that into my head, the Baker's percentage. And I think she's back in Reno now, so if I get her to come in here, I'll get her to come in this year and prove to you that I'm not lying when I talk about the baking percentages. She texted me one night and says, "Thank you." Okay, all my fellow classmates are still trying to figure this out, even though I helped them. I'm done. I'm out partying. So it's something that you need to keep in mind and to keep notes on, keep it in, your head. Many commercial formulas, especially those for cookies, cakes, and breads, list ingredients as a percentage in addition to or in place of a specific weight or volume measurement. Percentages make accurate formula conversions possible, and percentages are also a convenient type of shorthand. At a glance, the baker who is familiar with the function of ingredients can tell how rich, moist, or crisp a finished product will be. For example, a cookie dough with a high percentage of fat in relation to flour will bake into a more crumbly pastry than cookie dough containing a lower percentage of fat. The simplest bread dough, made with flour, water, salt, and yeast, will bake into a crusty loaf with a crisp crust. When even a small percentage of fat is added, the loaf will become more tender and the crust will be less crisp. When formulas list ingredients in proportion to other ingredients, the experienced baker can select formulas with the proper ratios for the product desired. The percentages may represent the true percentage of the baker's percentage in the true percentage method. The percentage of each ingredient is calculated based on the total weight of all ingredients in the formula, with the total being 100. The percentage formula most commonly used in the bake shop is called the baker's percentage. When using baker's percentage, the quantity of each ingredient is expressed as a percentage of the total amount of flour used in the formula. The weight of all ingredients must be the same unit of measurement, such as ounces, grams, pounds, kilos. The flour in the formula is always 100%. If a formula calls for 2 or 3 types of flour, the total of all the flour equals 100%. Calculating baker's percentage. Step 1. Identify the weight of the flour in the formula. the weight will be 100%. Step 2, assure that the weights of all ingredients are in the same unit of measurements. Oops, went too far. Step 3, divide the weight of each of the other ingredients in the formula by the weight of the flour. And step 4, multiply the number obtained by 100 to calculate the baking percentages for each ingredient. The weight of ingredient divided by the weight of the flour times 100 equals the baker's percentage of the ingredient. Let's take a look. The formula for sugar cookie dough, shown here, sugar cookie dough, yeah, there we go, needs to be converted to baker's percentage so that it can be scaled up. Determine the weight of the flour, which is 100%. 1 pound, 16 ounces of flour equals 100%. Okay. Divide the weight by the sugar by the weight of the flour. 6 divided by 16 equals 0.375, or 37.5%. Now here's the trick. When you're using a calculator on this, it's easier to do it with a calculator, but you must know where the decimal falls in a percentage. So the answer, if you put that in a calculator, would be 6 divided by 16 equals 0.375. Now you know when you're talking about 100%, you're moving that decimal point over to the left, or to the right, 2 places, and that gives you 37.5%. Okay, that's how you're converting decimal back to percentage. Multiply the number obtained by 100 to obtain the baking percentages for sugar. So 0.375 times 100, that's how you get the 37.5. Sorry, I was jumping ahead a little bit there. That's because I do it a little differently. But yeah, you can multiply it by 100 to get the 37.5%. Calculate the baker's percentage for each of the remaining ingredients. Butter, 7 divided by 16. Okay, and vanilla extract, 1 divided by 16. It's going to be a much smaller amount. An experienced baker will know at a glance that this sugar cookie recipe with 44%, or 43.7, basically 44% butter, will be more tender and crumbly than one made from a formula with just 20% butter. With 37.5% sugar, this cookie dough will be sweet and somewhat crisp, but not as brittle as a similar cookie with 60% sugar. Here you can see that converted. So now we started with 20 cookies, 1.5 ounce each, and our new yield is 48 cookies, but we want them 1.5 ounce each. So the old quantity is 1 pound, 14 ounces of dough. Our new quantity is 71.9 ounces. Or 4 pounds, 7.9 ounces. We're going to round that up to 72 ounces of dough. 4 pounds, 7.9. 4 pounds, 8 ounces of dough. So that just, it rounds up the flour, and which is the one we can really round up. And we can round up the butter, and you see how we round some of these up. Vanilla extract, we wanted to round down, not up, because if you go up to 2.5 or 3 ounces, you're going to have way too much vanilla in that product. And it's going to make it taste a little bitter, especially with using extract. Okay. So some things we round down, some things we round up. Okay, sugar down. We don't want them too sweet. Butter can go up because it just raises the fat content a little bit. And then the flour can always go up because that's kind of your base. That's your 100%. Okay. Other ingredients. Fruits may need to be peeled. Okay. Yield test always determines the usable portion of an ingredient because we have it as purchase price where we purchase like those 40 pounds of lemons, 115 count. Well, we don't get to use the whole lemon. Okay, it's like an onion, a potato. We have to take the peel off. Fruits have to be peeled. We pay by the pound for our fruits, but peaches and pears, all those stone fruits, have a pit in them that we have to cut out. So when we're weighing that, it's going to be the edible portion, is what that's called. What can we eat after it's peeled, cleaned, seeded? What is the edible portion? So if we take that edible portion and compare it to the as purchased, we can get a yield percentage. So edible purchase quantity divided by a yield percentage is the as purchase quantity. So that, formula can go either way. If you say I need 10 pounds edible portion, my yield percentage is 50%. If I divide it by 50, I'll get my as purchase how much I got to buy. Well, that's going to be 20. Because if I get a 50% yield, that's a terrible yield. But that means I got to buy 20 pounds of something to get the 10 for the edible portion. Okay, so knife skills we're not going to talk about much. I do want to talk about kitchen techniques. Focus on the task you're working on. Use the correct equipment and knives. Always cut away from yourself. Cut on a cutting board and keep your knives sharp. Okay. All right, so that's about all I think I've got for this section. Except for, when you're preparing your equipment for mise en place, make sure you're preparing your oven. Preheat your oven. Adjust the oven racks to fit what you need. Coat pans, molds, and baking sheets. And line muffin pans with disposable paper. All right, that's good enough for today. Thank you. Have a great day, guys.